Throughout history, technology has played a big role in the ability of financial institutions to offer their services. But for the most part, banking has remained the same for the 500 years from the 1450s to the 1950s. But then, when computers were invented, banks were among the first to take the step to use computers to revolutionize their processes. However, the pace of technology development has exploded in the time since, and where the banks used to be at the forefront of technological adoption, increasingly they are beginning to run behind.
I think that banks have a reputation for being sort of somewhat technical laggards and their technology isn't that good. Actually, that's fundamentally wrong. Banks were at the forefront of computer technology when it first came out. Computers really came out post-Second World War. And what computers are very good at is tabulating large amounts of numbers. And if you look at a bank, what does a bank do? It really needs to tabulate large amounts of numbers in a ledger, so on and so forth. So it was quite an obvious thing for banks to do, to say, actually, we can use these automated telling machines, these banking machines, to be able to add up everything that a bank does, all the overnight ledgers and so on and so forth.
50, 60 years ago, banks were the forerunner. They saw the need to utilize the IT at that time, the hardware and the software. What they did was they moved one application at a time into the hardware. They would do the deposits, i.e. checking and savings. They get that done, they would move in the loans, general ledger, ATMs, and so forth.
And then, what happened was that someone came up with a project. I want to do something else. Right, what we'll do is we'll put it next to this piece of logic in the computer. And then they want to do something on the marketing side of something. Right, we'll add that piece of logic in here. They want to do something on a credit scoring change. Right, we'll put it in alongside our clearing algorithms and so on and so forth. And at the time, that made sense because actually we're just changing small amounts of programs. But what happens if you do that for the next 50, 60, 70 years is that you end up with a spaghetti mess of software that is all very tightly bound together. New technologies have been added in, and basically you cannot unwind.
Many banks are struggling with their so-called spaghetti legacy in their core banking systems. The main coding language that underpins the mainframe level, at the center of the spaghetti legacy, is COBOL. This means if you want to make changes to a banking mainframe, often engineers need to use COBOL, an old coding language, rather than the more popular coding languages of today, such as Java, Python, Scala, and others.
People laugh at me for this. I don't call it legacy COBOL, I call it legendary COBOL.
This is Bill Hinshaw, founder and CEO of COBOL Cowboys, a company that provides professional support for legacy COBOL systems.
When we go into an engagement like that, knowledge, like Elvis, has left the building.
There is a lack of COBOL coders due to the age of the language, and over time, colleges and institutions phased out the teaching of it, meaning very few people now actually know how to write and use it.
Our average age for COBOL is probably 55 to 59, because everybody was under the impression COBOL and mainframes were going away. Experts said that they would unplug the last mainframe in 1996, and that mentality influenced the colleges and the universities and the younger generation. We are getting calls from the young generation just out of college saying that they felt that their IT education was lacking on the COBOL and the mainframe side.
50 years since its inception, many banks and huge organizations are still relying on COBOL to keep their mainframes up.
92 of the top 100 banks, 92 of the top 100 banks rely on mainframes and COBOL. Of those banks, they say that they see using COBOL mainframes for at least the next 5 years, and some are saying they may not move off of it. So, in fact, even today, for card swipes, your credit card, debit card, through a point of sale or an ATM, 90% of those still touch COBOL and mainframes at some point. And you're also talking about replacing 200 billion lines of code in COBOL. So COBOL and the mainframes are still they're actually running the world, to be honest about it. So,
at the same time as COBOL was starting out, computers were fairly new and expensive, and developing software for the mainframe became a very cautious and risk-averse process.
Because the mainframes and systems that the big banks and other enterprises use were very expensive, They typically put together a set of change processes that were tightly controlled. There was a belief that actually you could specify a lot of the problems up front, you could design those problems up front, and you could build for them, and then it's simply a case of rolling it out. So you had a waterfall set of steps.
The waterfall model is the name given to the sequential software development methodology, coined in 1970 and commonly used by banks, where specific goals are set for each stage, which can't be revised after they are completed, and all steps need to be completed and signed off before a rollout can take place. This time-consuming methodology with so many checks at each stage is highly risk-averse, and testing is usually at the end of the process, which makes it difficult to make changes. However, this complemented the mindset of the time of protecting the mainframe at all costs. And, as mainframes were the default, this is the method everyone used.
The problem occurs when someone else comes along and does something different. Now, up until kind of the mid-1990s, the only way you could build a reliable computer system was to go out and buy something very expensive from an IBM or one of the big system softwares, Oracle databases and so on and so forth. Brilliant piece of hardware, brilliant pieces of software, very, very, very good at what they do. And these systems were designed such that you could pretty much run an entire organization in one mainframe. In the mid-90s, the world changed. And the thing that changed was the internet. And the reason that it changed really was you started to get problems that were bigger than a single mainframe could handle. Once you get to the point where you have to split a mainframe up into multiple parts, it becomes a much more harder, much more intractable problem. What's quite interesting, I suppose late 1990s, there were two guys in San Francisco, in Palo Alto, called Larry and Sergey, and they had this problem whereby they had a search algorithm. Search works very well because you can do things in parallel. They couldn't afford to buy a mainframe, but what they could afford to do was to buy a bunch of very cheap computers who could each do an individual part of that program together. And they realized that actually by bolting together lots of these computers in parallel, who they could buy very, very cheaply, they could effectively mimic what a mainframe does for their particular part of the business. So these two guys were Larry Page and Sergey Brin. They founded Google. Google is built on that distributed system.
By being forced to find a new and cheaper solution to buying a mainframe, the Google founders championed distributed computing and proved it can be done in a way that can match mainframe speed and cost. And these methods changed the game.
How we built things inside of Google from the start was around the concept of containerization. That was a completely foreign and new topic in financial services. Where Google started changing the game is bringing the concept of, hey, if you made it into these mini, immutable parts, you could put them all together like a puzzle pretty quick all over the place and then switch out the pieces. You think about the old software development cycle, right? You look at these things and they would take like 2 years to roll out the new mobile banking app, right? When it first came out. When you do containerization, you can take each part of the mobile banking, like the front end experience, the how do I do deposits, how do I do withdrawals, right? And you can create a container for each of those and then you can roll them out. It doesn't have to be this giant monolithic, here it is, one thing, big bang, and then hope that you got all the features right? It allows you to have these constant rolling feature updates. And then it also allows you to adapt quickly because you can change the feature because it's small enough. If somebody, if your customers are like, oh God, this is the worst thing ever, or, oh, I wish these 10 things, you could do it. It allows you to do the adaptation, right? Even on what you've done so that that whole cycle, you can shorten it.
Alongside this flexible way of working, a new approach to software engineering was created in the early 2000s, known as Agile. Agile is a methodology that, unlike waterfall, was more flexible and adaptable, and more of a mindset than a set of specifications. It is a dynamic and iterative process with continually implemented feedback, allowing you to make changes and test as you go, rather than at the end. We now know that Agile has changed the game for software development, but at the time, not everyone was bought in.
Because the entire computer industry and everything that everyone knew, it was only sensible and rational to have big bang waterfall style releases. There were people who were starting to explore this smaller compute type mechanism, the stuff that would ultimately become cloud and ultimately what Google would use and so on and so forth. But that was considered crackpots and hippies and madmen did that. Why would you engage and build this stuff when everyone knows the reputable way of doing it is to buy a big enterprise software from big enterprise companies who would sell you this stuff, They put big support contracts around it. You're spending a lot of money. Or you could basically play with a set of toys, that kids play with.
The companies using these so-called toys evolved into some of the world's most successful. But for a long time, banks stuck to their guns and didn't use these iterative processes. Their only real competition was each other, and so the status quo persisted. Until a perfect storm of regulation and technological change gave rise to a new set of players. Enter the fintechs.